Guys, you're looking at Hoover Dam, and this is fairly recent video. It's down quite a bit, guys, and we're around 1045. It's about a 5 feet drop so far this month. Since June 1st, we were at 1050. We're getting it very close, but the water's a little lower than what this picture is indicating, and this was taken at 1050 right around the 1st of June. Now, what I'm going to talk about here is some of the same things we've looked at, but going into a little bit different detail, which kind of clarifies it. I know sometimes the data and the details can kind of get bogged down, but I think it's kind of important to see how quickly that a hydropower shutdown at Mead under the current conditions can happen, and how quickly the three tiers of what they call electricity power warnings go out. You got your tier 1, tier 2, and tier 3, which will be right behind that. And tier 3 is almost complete loss of Southwest Desert power. So we're going to take a look at that, guys. Hang tight and give you this information. And guys, these are called shortage tiers that are defined by the U.S. Bureau of Reclamation to manage water delivery while hydropower electric drops along the following elevation thresholds. Now, we know at 1035, the standard narrative is that we lose all but 5 of the big turbines. 17 turbines there. The 12 lower ones will have to be shut down. Then you got what they call wide head turbines. But they're saying that will cause, with just 5 turbines, a 70% decrease in hydropower. But what they're not calculating is that they have only 4 turbines, because one of those top 5 are down for construction or reconstruction, and costing $52 million, and they're saying it won't be up until 2028. By then, more than likely, there won't be a whole lot of reason to have that thing there. I'm sure that money will be used very wisely. But again, when we get to 1035, things start to change very quickly. Now, like I said, instead of 5, what they call a big head or large head turbines, you only have 4. So that puts that cut from 70% downstream for hydropower to up to about 81.8%. Think about that, less than 20% power just coming up in maybe 4 or 5 weeks. Think about that. Now, that has implications of its own that we have not discussed in detail. Now, let's look at these tiers a minute. Again, they're called hydropower generation tiers. But below 1050, Hoover Dam output is significantly impacted. That happened June 1st. We are 11 feet now above, not quite 11 feet above 1035. And here, output drops 58%, guys, but that was before the new information and the other turbine. But this number is a little bit off. I'm just using data, okay? It was jumped up to 70%. Now it is 81.2% because of that 5th turbine loss. Outputs dropped by 58%, it says. Again, it's going to be 81, leading to a loss of power supplied to Arizona, Nevada, and California. 950 feet again, Hoover Dam completely ceases generating electricity. Now, we're a little bit of time away from that. We're not very far from 1035, and that's where it starts to become crucial. Because remember, they're going to sacrifice Mead to save Powell. But looking at all the data, Powell will not be there very long because of no snowfall last year getting to the rivers, and with the satellite views showing us that the moisture is blocked from not only the Pacific, but also from the southeast coming up out of the Gulf of America. Now, because the desert Southwest grid is heavily interconnected, including natural gas, solar, and imports from other regions, grid operators like the Western Area Power Administration, they call it WAPA, manages the reduction without rolling blackouts. That's if you start having minimum problems. Now, we mentioned in a previous video talking about the Antarctic being 36 degrees above normal, how the El Nino is a global radiator, and how those tentacles reach in both north and south from the equator. You saw the darker lines bringing that heat into the Antarctic. Well, that it's also reaching north. So one factor is causing all of these earth changes. And the El Nino, guys, comes from heat energy, which is our sun. Without that, there would be no earth as we know it, and there would be no El Nino. Anyway, if Lake Mead breaches the 1035-foot tripwire, I'm putting in the new data now, triggering a massive 70 to 80% loss in Hoover Dam's hydropower capacity during peak midsummer demand. That's important. Now, guys, when does that happen? That peak demand from Hoover, guys, is not in that heat of the day in that early afternoon. It's when they start losing solar power. They have massive solar fields, battery storages, and things like that that they rely on heavily. But as the sun is setting, it's still hot, and the air conditioners are still running. So that's when they normally would kick in that instant hydropower. In other words, as soon as they release more water, the turbines increase, and that electricity is sent downstream. Now, what is happening is the sun sets. Now, again, that kicks in. And here comes the strain effect, guys, because at 10:35, Mead is going to be shutting down, right? That late evening, when the solar power's dying off and they need Mead the most, it won't be there. So it's going to put a strain throughout the entire Southwest desert electrical grid, going from, I guess, basically Utah down, maybe a little further. All of that area would be affected. And guys, the dams above Flaming Gorge are in trouble now. They were relying on a few places, and they're in trouble. Anyway, so our late evening hydropower kick-in will be gone. Extreme stress on the remaining grid, even though they can switch pretty quick to natural gas, coal, nuclear, battery backup, things like that. That is limited, especially when we're talking about 80% loss of hydropower. It says because hydropower provides immediate grid balancing capabilities during the hottest hours of the day, the sudden deficit would force utilities such as Nevada Energy, APS, or SRP, which is Salt River Project, to escalate through specific energy emergency alerts called EEAs. That's what we're going to get into. Now, what will be the first things that we see? It's called pre-emergency stage or flex alerts and conservation appeals. Before the formal grid drops into emergency status, local power companies will issue widespread public service announcements. Again, the alert would be flex alerts / voluntary conservation request. Request still at this point. The message is that utilities will send text alerts and push notifications asking consumers to voluntarily reduce power consumption between 4 p.m. and 9 p.m., the peak window when solar power drops off and the missing hydropower is most critically needed. And they're saying for the consumers like us, avoid using large appliances, washers, dryers, turn off unnecessary lights, and set thermostats to 78 degrees or higher to try to prevent what possibly cannot be prevented, but at least it could hold it off for a little bit. Now, if these voluntary requests are not heeded, we're going to go into grid level 1 emergency alert called EEA1, okay? If voluntary conservation is not enough to offset the missing hydropower, which it will not be at first, guys. People want to stay cool. The balancing authority will declare an EEA1. It's called an energy deficiency warning, meaning we don't have enough. The message of the grid operator communicates to the market that all available power generation resources are online and committed. We're at max, but the region is running dangerously low as operating reserves. Power companies begin buying high-priced emergency power. We've talked about this from neighboring states and importing electricity via interstate transmission lines. There's a problem there. One is the cost. Hydropower is the cheapest power on the planet. So, of course, prices are going to go up. But what's going to happen transferring grid to grid? Guys, we got ancient transformers. We talked about that. We're going to have grid problems. Now, I'm not going to try to draw this out very long, but let's go to Emergency Alert 2, EEA2, called Grid Level energy emergency alert. Remember that. If reserves continue to shrink past this grid 1 level, and the grid cannot import enough power to bridge the gap, the emergency escalates to an EEA2. The reason I'm doing this, guys, is I can see it coming just as clear as day. It says the message, power companies issue urgent, high priority public warnings, not requests, warnings stating that grid conditions have severely worsened and the threat to power stability is real. Again, EEA2. The actions include the utilities will trigger demand response programs. What is that? They forcefully cut power to large industrial customers who are on interruptible contracts. In other words, contract states we can cut your power under emergency. Not all large companies, especially if they have national security interest, you know what I'm talking about, not all of those will be forced to shut down because of national security. They forcefully, again, cut power to these large industries in exchange for cheaper rates. They may also initiate public conservation programs that automatically adjust smart thermostats like Nest or Ecobee for participants. Isn't that very handy, and didn't we know it was coming? Now let's go to grid 3, but guys, we're talking about these smart appliances. I don't have them. Okay, I guess having a smartphone is one of them. But the Ring and the Echoes and all those little devices like that, they can, they got them that can adjust your water temperatures and everything. Guys, those are traps. If you got them, I would start replacing them immediately. Go back to the basics. Get that out of your system because you are not in control. I'm just telling you now. But let's go to grid level 3, energy emergency alert. It's a final critical step used to prevent a total catastrophic grid collapse. If the power supply cannot meet demand, the grid operator mandates this EEA3. And this means rolling blackouts are imminent or in progress. Wireless emergency alerts, called WEAs, similar to Amber Alerts, will blast directly to mobile phones. The notification will state that controlled rotating power outages are actively being deployed to protect the integrity of the Western grid. And that's how it's all tied together. You get a major breakdown in any section, it affects everything, like losing 80% of the power from Mead, and it will be 100% very quickly. Anyway, what action will happen? Utilities intentionally drop power to predetermined blocks of neighborhoods for 15 to 45 minutes at a time before rotating the outage to a different block, protecting critical infrastructure like hospitals and water treatment plants. That makes sense. Now, the blackouts won't be the greatest risk. It will be an inconvenience, but what we're looking at, guys, is old grids. Remember that as you're switching through these things and putting more power into one section to handle the dropout of other sections, you increase the fallibility of these old systems. But the real threat is peaking power and inverter risk. The speed at which an EEA3 could arrive depends entirely on when the power is lost rather than the total amount. And guys, did you know that the El Nino will have an effect on this? Because heat has a lot to do with transformers and inverters. And we got El Nino has set up a blocking heat dome over the desert Southwest. You've seen it a dozen times when we look at the NOAA wind speed map, showing all that whole area of the desert Southwest, north to south, is in brown, and all the moisture is being blocked from the Pacific and kept over to the southeast. But it says the peaking problem, Hoover Dam's primary value isn't baseline electricity. It's, again, used as the peak power. Utilities spin up the hydro turbines instantly between 4 p.m. and 9 p.m. when solar production drops off and air conditioner uses peak. People are getting in from work, cranking up a little bit. According to recent NERC grid stability alerts, this is really why I'm here, regarding inverter-based resources, the risk isn't just the missing water. The risk is that a different part of the grid spikes or falters on a hot July evening. There won't be enough rapid response hydropower to balance that system, potentially causing a fast-moving, cascading regional issue. Now let me explain this just a little bit. In my solar system, it comes in as DC voltage. And the whole point of a solar system is to bring it in, let the inverters charge, the charge controllers charge your batteries, let that energy go into the inverter, which is a big transformer. And it's a balanced transformer. So when I feed that energy into my breaker box inside the studio here, you can't put all the heavy loads on one side, like say the bedroom air conditioner and the studio air conditioner over on one side of my box or on one circuit of it. Not just one circuit, but one side of the transformer, because when I came out of my inverter into my box, everything had to be split. Coming in 220, coming out 110 on different sides. Well, you can't put all your loads on one side. In other words, I couldn't just run the computers and the studio on one side of my transformers and put all the heavy loads on the left side. It would overbalance everything and destroy my system. The same thing is what they're concerned about. Again, according to recent NERC grid stability alerts regarding inverter-based resources, and that's what we're dealing with at Mead, the risk isn't just the missing water. The risk is that a different part of the grid spikes or falters on a hot July evening, just like my misbalanced loads if I did that. There won't be enough rapid response hydropower to balance the system, potentially causing a fast-moving, cascading regional issue. Now, guys, when you get a transformer out of whack, all of these desert transformers and power transformers work on a frequency of 60 hertz. It has to maintain that. If it drops to, say, 58, guys, they have to shut everything down or the equipment will burn up. In other words, you're getting a little less power to all the big engines, the turbines, the generators, and everything else, right? But you mismatch that voltage. You let it drop below 60, 58 point something, right in that area. And if they don't shut it down instantly, guys, it starts melting all the coils. It actually, the heat builds up. It will melt the rotors and the turbines. Everything in the system could go down just like that. And guys, one of the things that could cause that misbalance in their inverter or transformer situation, guys, in these big coils, is that, listen, if Lake Mead breaches 1035, the level 3 alert will not arrive fast because grid operators can safely absorb 1,660 megawatts loss under market imports and national or natural gas peak plants. Now, what would happen though is, this is why I brought up the old grid. It would only happen rapidly if the hydropower loss collided with a concurrent disaster, such as a major interstate transmission line failing or a historic multi-state heat wave, like the El Nino now, melting the South Pole, causing this heat dome. If this heat wave taking offline other power plants simultaneously, then there's your mismatch. Then level 3, it's really past that at that point. It's shut it down or burn it down. Now again, when you shut down that much, it's going to slow down the rotation of the massive turbine generators. They operate at 60 hertz, remember that? And the physical rotation of these turbines has slowed down because the mechanical power of the falling water cannot keep up with the electrical drag of the power grid. If the North American power grid, the frequency is a real-time indicator of the balance between electricity generation, and it is, guys, they watch that very closely, and consumer demand, it must be maintained precisely at 60 hertz. If the dam's output drops below this threshold, it triggers an immediate automated and high-speed safety sequence to prevent physical destruction of the power plant and the total collapse of the Southwest power grid. Guys, we talked about many times in the series about when Mother Nature gets ready to shrug, then she will attack you from every direction needed to save the planet. That's what we're seeing. We've talked about the record-breaking El Nino, and they're classifying it now as a global, worldwide radiator, right? We saw the tentacles reach south into the Antarctic, reaching north up to the Arctic, and putting this complete heat dome over the desert Southwest. Now that again increases heat, but it increases it in a few different ways than you normally would think about. Extreme heat degrades electrical transformers by accelerating insulation breakdown and reducing operational capacity. During events like El Nino, which exacerbate global temperatures, record-breaking air conditioning demands compound this heat, severely stressing the power grid. We've talked about it. This combined thermal and electrical stress often is a trigger for localized blackouts or rolling outages. But let me say this. We've talked about this too, the 14,000 peaks, southern Colorado, 2 miles up. Normally, they're just now getting the melt going on and start replenishing the streams. We've been through that, right? But that melted off in March and did no good. But what does it happen? So we got a global radiator. Picture this setting in the Pacific Ocean. It's trapped a heat dome. Now, you look at 2,000 feet, 14,000 feet, over 2 miles up into the Rockies. And as the snow was there, it kept the upper atmosphere cool. Also, it radiated heat back out, one of the things, and the temperature of it. It kept the upper atmosphere, remember that, we're going to look at a map, kept the upper atmosphere cooler. But now with no snow, what was little was there ran off in March because of an unprecedented heat wave in March. Now you got the sun hitting gray rock. Think about it. Any rock under sunlight, just like whether it's Grand Canyon or wherever it's at, is going to heat up the entire environment. So now instead of a cooling system the length of the Rockies at upper elevations, we have an extended arm of the global radiator. We're calling the Super El Nino. So now the tops of the Rockies are hot. That's going to inhibit snowfall. What it will do, if you get a little bit of rain, that slight temperature rise is not really that slight, but that temperature rise will melt the snow. The compounding effects of these severe weather anomalies on equipment in the desert Southwest include the following. Accelerated insulation degradation. Transformers are typically rated for ambient temperatures around up to 104 degrees Fahrenheit, or 40 C. When extreme desert heat pushes past this threshold, the internal windings and cooling oil overheat. Again, we've been through that. Now we're looking at how everything's locking into place. To where, again, an El Nino monsoon may be a quick, fast runoff that does nothing for the rivers much and absolutely nothing for the reservoirs. And the fact that because now we got a trapped heat system surrounding the desert Southwest, you've got mountains in California, you've got mountains in the Rockies, then that dome is going to stay in place. They can't take it. You still have the 24/7 demand from some heavy duty manufacturing, things like that, but they will not have the nighttime backup power of Mead. You understand what I'm saying? And that's going to, again, the word they use, exacerbate everything. And these power companies have what they call a rule of 6. Studies indicate that for every 6 degrees Celsius rise above a transformer's maximum rated hotspot temperature, the rate of aging doubles. They'll do it to your solar batteries too, unless you keep them inside, which temp controlled. That puts a 40% or 40-year lifespan on these transformers. It cuts it by 20 to 40% as you extreme prolonged exposure to heat. They're already at that, many are at 40-year lifespan. And some people will say, well, they've seen new power lines being put up, new, more modern, and they are doing that, guys. But if you look back at the base hookups, like Mead, you still have a weak link. They still have to have power from somewhere. And this diminishes the capacity and efficiency. This is where it gets down to where that 60 hertz balance can become critical. You start getting massive downtime from one grid, or grid to the left or grid to the right of a big separation point, from a single source like Mead, sending it to maybe parts of California or parts of Arizona. One of those goes down, you imbalance that 60 hertz transformer. That's the point of coming into the heat thing. They don't talk about that particular busted fuse in the system. But this efficiency of power delivery drops as the transformers age, meaning the heat equipment or the equipment delivers less electricity while generating more waste heat. You get a line sag. High ambient temperatures cause the metal and high voltage power lines to expand, leading to significant line sag that can touch vegetation on the ground and result in fires of outages. A few days ago, I saw that we had 70 across the U.S. in very dry conditions that cannot be easily handled, again, from every direction. So I want to refresh you guys. We do this in a lot of the videos going back for the last few months, is look at this one chart, maybe two, and it shows how much moisture is available, called total precipitable water. And the blue and green, that's where your moisture is around the heated El Nino. It's pushing all of that further north. See that? And look at the pressure setting up here, pushing everything to the east. This boundary has got the southwest trapped. Now we're looking at it at a certain height and pressure called 500 HPA. I've talked about that, but again, look at what has been set up and trapped. The heat is pushing upward from the El Nino, warming the Pacific Ocean. It's getting trapped here. See the lighter browns pushing into California? Same thing happening here. Very dry over Mexico. That's being pushed into the moisture, but it's not making it to the very, very dry areas. And where is it being stopped at? Along the Rockies. And again, the Rockies now have turned in from a cold or from an air conditioning system basically to a heater system. Look at it. And again, look into Canada. Everything is almost being blocked from, again, the Pacific, both the North Central Pacific, and from this area here. The fact that El Nino is pushing everything to the east isn't blocking the moisture also. Now let's go just a little higher, because if you look at it at what's called 500 HPA, remember this, and you go to 250, which is a lot higher, and you still see this moisture lock, then you know it's locked and it's going to take a long time. An average El Nino, guys, can last 12 to 15 months. This one is not average. Even at 12 months, it doesn't make it through the next snowfall. In other words, this will be a continuing disaster that's speeding up daily. So let's change heights. And so you've got both sections of the jet stream locked in now. Both are showing the exact same thing. If there were upper atmosphere or atmospheric moisture, it would show up on this. But the jet streams are so powerful, and they are, remember we talked about this, talking about the Antarctic being 36 degrees above normal. It locks in the jet streams as well as the ocean currents. It's a symbiotic relationship between every form that nature has. Water, heat, moisture, all of those things are locked in together to keep the earth alive, to keep it where it can support life. And if we cut off some of this information, guys, and just stop the lines that show you where the heat's moving, you can see the drought even better. Look at that. This is called that dry quarter, where they're preparing food for millions of people, but they've got a lot more people than they do food. You can see the driest areas are right through here. And we pull this up, guys. Again, everything's locked out. Here's your basically the Colorado River Basin, and nothing's getting past it. Nothing right now, and the heat is still increasing. And the reason it won't get past it, let me turn this back on. Look at that. There's no way for it to. And then going back down into the lower elevation there, will drop even further. It's just all being pushed that way. And I'll go all the way to the surface level. And let me back it up just a minute. Again, it's just a trapped heat section, surface layer. No moisture coming in from the Pacific. Everything's being pushed back across the Colorado River Basin here. Come up 1,000. Same thing. We're going to increase as we go. Again, you can see the heat is being what's pushed into California in the desert, not the moisture. Raise it a little bit higher, same thing. Nothing coming in. A little higher, same thing. Then back to where we started at 500. But guys, it's locked. This is called an atmospheric lock. It's not changing at any altitude. That's not good. The jet stream patterns are broken. And if we back out and look at the whole globe, here is where we're focused at, where the green circle is in the desert Southwest. You can see how it's picked up in the upper levels and pushing the moisture that is coming from the Gulf of America and the Caribbean and Southern Atlantic back out to sea. You see that? And look how dry it is above that. Now there's a lot of moisture setting here, just while we're looking at it, for hurricane strengthening. If it can slip past some of the high pressure, then we're going to see some pretty powerful storms. Look how long, and it still basically is lasting. The moisture here in the southeast coming in. Everything that's being trapped in the southwest is being compressed with our normal moisture, and that's why we're seeing continuous rain. And just quickly look at South America. Look at the sections here. And looking at it at high elevation, everything's kind of trapped in place. It's too warm, 36 degrees above normal. But guys, we're watching it. I just wanted to point out the fact that now we got to watch for different things like the frequency of the transformers in the motor and the coil windings stay at 60 hertz, even if you have one leg of a complete electrical transfer system go down. That can happen. And what are we leading into? That very scenario. And we're watching it, guys. Our Father loves you. I love every one of you. It's a heads up. And be safe.